Hello, everyone, and thank you for joining again into this exciting session. A couple of colleagues and a lot of people on the community has reached out to me asking if I can put together a demo around Swift. It's a pretty good topic to be discussed. I'm sure a lot of you already know that Swift is our object storage. It's not really. When a lot of people discuss, they still think that Swift is still not a part of the OpenStack, but it makes a lot of sense for the Swift to be installed while we are installing OpenStack because Swift is a perfect backend for a lot of object storage, especially like you're talking about the images where you don't make a lot of changes to the image. So it's a perfect medium where you can go ahead and store. So in today's demo or lab, I will walk you through with the installation of a Swift node. In this demo or the lab, I'll be using one single VM that will be doing all the work for us. It's going to act as your Swift proxy as well as your Swift storage node. So if you have a look on it shows this is my VM, and on the same VM, it's going to be like a shared services. So we will be using Keystone for our authentication piece, and Swift will be using the Keystone for all the authentication and authorization piece. Then the same VM is going to run Swift proxy services for us, and the same VM is going to service the Swift stock storage also. We'll be doing an SSH to access this particular VM. I have configured this VM. I have configured a lot of things for us just to save some time. So this VM is running Ubuntu 12.04 5 LTS 386, and I have updated the iSauce package on this one already. I have MySQL database installed, up and running, configured with certain details, and I'll walk you through with those. I have configured the RabbitMQ and the Keystone. I'm sure a lot of you already knows how to install RabbitMQ or Keystone. In case you need more details, you can refer to some of my earlier presentation and the demos, or there is a lot of material already on the YouTube, or you can reach out onto the official OpenStack.org website on docs.openstack.org. You will have plenty of good information out there too. So let's go ahead and start, and I'll walk you through some of the pre-configuration that I have done, just in case if you'd like to play around later so you know what exactly I have done. Though I'm not going to spend a whole lot of time talking, I'll just walk you through with all different steps that I have done so you are familiar. So I went ahead and installed the Python repository. So as you can see, I did an apt-get install -y Python software repositories. After that, I went ahead and added the iSauce repository, add app repository, cloud archive, iSauce. Updated my cache on this machine using apt-get update and apt-get distribution upgrade. After that, I went ahead and rebooted this particular VM. Later on, we went ahead and installed the MySQL package, so apt-get install Python MySQL DB and MySQL server. So we had installed the MySQL server with the all Python libraries. Later on, I went ahead and edited my MySQL.cnf, and I added certain details, like as you can see, uh, default storage engine I have changed to NODB. I have changed to the UDF8. Character set is again UTF-8, and I'm binding to my ETH0 IP address of this particular VM. After that, I went ahead and restarted my SQL services, making sure all the changes I just made to my SQL's configuration file gets applied. So that's all pretty much I did on this side, and there's one more slide on this side. After the installation of the MySQL, I ran a few of these commands to make sure I did a database installed and make sure my installation is secure. Later on, just simply went ahead and installed RabbitMQ. A lot of you are already familiar. If not, I would strongly encourage to watch some of my previous demos. or look out for some other material on the YouTube or on the community. I just went ahead and simply changed the password for my guest account to rabbit password. I went ahead and installed the keystone. So in this demo or the lab, I will not be walking through with all different pieces of keystone and the configuration. And I have mentioned earlier and just like to rephrase same. If you need more details about keystone, I would strongly encourage to watch my previous videos or presentation on this topic, which I have given in a pretty much great detail. So that's all pretty much. Let me go ahead and start sharing my putty and we'll get started with the real Swift installation. So give me a sec. I'll go ahead and start sharing my putty session with you very shortly. And I hope a lot of people are able to see my screen. Perfect. So that's good. And as you can see, this is my node, which is running the version that we discussed earlier. That's my local IP. So on this, I just got an Ethernet 0 with an IP that I have configured with a broadcast gateway, mask, and my default. And we kind of walk through all the different pieces. Let me just walk you through some of those things that my keystone, we need to make sure that the keystone is installed and up and running. So let's go ahead and do a keystone user list just to see what are the different users I have on this one. So I got a demo and admin are the users. Let's find out what are the tenants. So I'll go ahead and run a tenant list just to make sure. So I have an admin tenant, I have demo tenant, and I got my default services tenant. We'll be using this later on. Before we walk through, as I mentioned earlier, that we will be using this VM as our Swift storage node. So I have provisioned, as you can see that I have provisioned 3 extra drives, dev SDB, SDC, and there is an STD, all are of 1 gig capacity. We will be using these drives later on for our Swift storage. So just want to make sure that you understand that I have 3 extra drive available to us that will be used as a Swift storage nodes. And I'll keep you on, we'll walk through and we'll do some of the other things. So the first thing we'll go ahead and create, let me just make it a little bit pretty small, hopefully all you can see. And I'm sure you all can see, but let me go ahead and increase my font size a little. I just want to make sure it's visible to everyone clearly. Okay. Okay. Sorry about that. So let me go ahead and create. The first thing we'll go ahead and create. Now we will be running the Swift on the same node. So we'll go ahead and create a Swifty user with a password of Swift pass, and we'll assign that to our tenant service with an admin role. So I'm sure a lot of you are already familiar with this syntax. In case not, I'll go ahead and walk you through. So keystone user create, we are naming as Swift, and the password we are using here is Swift pass. And as you can see that we just created a user by name Swift with the name of Swift, and this is the ID. Now let's go ahead and assign a role. So we'll go ahead and run keystone user role add command. For the user Swift, we are assigning a tenant of service with the role of admin. So let's go ahead and press enter. Make sure everything looks good, and yep. Like the way we had done in the past, now Swift is nothing but another service, so we will go ahead and create a service. So the command is again as pretty simple, keystone service -create. We'll go ahead and give it a name of Swift. Type here is object store, and then we'll go ahead and assign a description. Okay, so as you can see that I went ahead and created this service. I gave a name of Swift and type object stored, so you can see the description, the ID, the type, and the name. Next, we'll go ahead and create an endpoint as usual. And again, just would like to rephrase one more time. If you're not sure what I'm doing, I would strongly encourage you to go ahead and watch some of the presentation demos around the keystone part, so you will get from a good familiarity that why we are creating these different services or the endpoints. So we'll go ahead and create an endpoint for our Swift service. So I went ahead and typed endpoint create. We pulled up the service ID using the service list document, which is nothing but this one. We went ahead and configured the public URL pointing to our 80 IP address. It uses port 8080. Same thing we have kept for our internet URL as well as our admin URL. And here we go. We have an endpoint created for our Swift. If you like to verify, we can go ahead and run keystone endpoint hyphen list to get some good details. So as you can see that we have the 8080. So as you can see here, we got the endpoint list for our Swift, and the earlier one is for our keystone. Now we'll go ahead and create a directory for Swift. I have noticed sometime when while doing the installation, this directory doesn't get created. So I'll go ahead and create this directory in before. And I'm creating a directory by name Swift under etc folder. So we'll go ahead and create this directory. Let me change it myself to the root user. And let's go ahead and create this directory. So I went ahead and created this directory. Now let's switch it to this directory at say Swift. And as you can see, there is no file. So we'll go ahead and create a file here by name swift.conf. So we are creating a new file here by name swift swift.conf, and we'll go ahead and configure some hashing details over here. So I have already typed some details, and I'll just go ahead and copy paste this information for us. Skip time, but I'll walk you through. So I have defined a hash for hash prefix and a suffix, and these are just randomly generated strings. But as my note says, use this or make something on your, but you should never lose this. So something to keep in mind. So I'll just go ahead and save this file. Now let's go ahead and install. So we have created a directory for Swift. We went ahead and created our swift.conf. We configured the hashing for the prefix and suffix. We specified some random strings. Now time to go ahead and configure the Swift storage node. And if you recall, we will be using the same VM for our Swift storage. So we'll go ahead and install some of our packages. So we will be installing the Swift account, Swift container, Swift object, and we will be using the XFS file system for that. So I'll go ahead and type the command. I have already written in my notes, so I'll go ahead and install that for us. So apt-get install Swift account, Swift container, Swift object, and XFS file system. So I'll go ahead and press enter. And if you notice, I missed the type Y. So if you had typed the -Y, you don't have to press Y. So I'll just go ahead and simply select Y over here. And let's wait. It's not going to take that long. It's going to be pretty quick. So our needed packages are done. The next thing what we need to do, if you recall, initially I showed you that on this VM I had provisioned 3 hard drives, SDB, SDC, and SDD. So we'll go ahead and configure those 3 hard drives so we can mount or we can use them for our Swift storage. So I'll go ahead and use our first disk, which is /dev sdb And just for if you see, if I do a print, if you see, we haven't defined anything over here. And let me press an M here. So I'm sure a lot of you already know. As you can see, there are different options. Oh, so I'll be creating a new DOS partition table. Sorry about that. So we'll go ahead and create a new DOS partition first. After that, I'll go ahead and create a new partition, and I'll walk you through with all those details. So let's go ahead and press on over here, which says create a new empty DOS partition table. So I'll go ahead and press that one. And now you can see building a new DOS label, and we got some details. Now let's go ahead and press N. That's going to create a new partition for us. It's asking what kind of partition do you want to create, a primary or extended. It's just a gig drive, so we'll go ahead and create only one partition. A primary partition, let's go ahead and give it a number. You can see the default is 1, so you can just simply press enter, or you can type 1. So I'll go ahead and type 1 and press enter. First sector, keep it accept default. Last sector, keep it default. Just want to confirm, press B again. And you can see that we have created device SDB1 utilizing whole space, an ID of 83, and type is Linux. Everything looks good, so just simply press W to exit out from here. Now we had created a drive by name SDB1, so we'll go ahead and create a file system on this one. So we'll go ahead and create an XFS file system. So let me go ahead and do that for us. So I'll use the mkfs command and go ahead and create an XFS file system on this particular drive, and you can see that that was done. Now let's go ahead and add this drive with the mount information to our HCFS tab, so it's persistent across a reboot. So I'll go ahead and add that information, or you can just simply go ahead and add the FS tab file and add the needed details. So I'll just go ahead and simply press and enter. And if you realize that we are mounting SDB1 on /srv node SDB1 directory, so let's go ahead and create that directory because this directory doesn't exist right now on this one. So I'll go ahead and create srv node SDB1, and then let's go ahead and manually mount this particular one. So we're saying mount /srv node SDB1, and if you type the mount command here, you would see that SDB1 is right now mounted using an XFS file system. And make sure that that particular folder srv node is owned by Swifty user with a group of Swift. So I'll go ahead and do a change ownership on that one. So we just need to repeat the same on our same sequence with the disk, our SDC and SDD. So let me go ahead and do the same thing. I'll go ahead and press O. I'll create a new partition, a primary partition. I'll press 1 over here, keep the defaults. If you want to confirm, press W, and let's go ahead and repeat the same thing. First, we'll go ahead and create an XFS file system, which is done. Now add this to the FS tab file. Let's create a directory for this one, SDC. So I'll go ahead and create a directory. Once that is done, let's go ahead and mount this to make sure we can verify by running the mount command, and you can see the SDC is mounted up and running. And again, let's make sure that folder is owned correctly by the Swift user and Swift group. And let's just repeat one more time on our SDD disk. So we'll go ahead and create a new primary partition, default 1, 1. Let's confirm W. Let's go ahead and repeat the same task again. We'll go ahead and create file system. Add to the FS tab. Create the directory. Let's mount this directory. And So we just formatted these three drives using the FS file system, and we have mounted these three drives on /srv node SDB1, C1, and D1. I'm sure a lot of you already know that Swift uses rsync for the replication, so we'll go ahead and configure the rsync file. Don't worry if you don't know much detail about the Swift. I have plans to cover this in a great detail in maybe a presentation, just walking through around all the theoretical concepts of the Swift. So just keep it hang it tight. I'll make sure I cover that sometime soon. So I'll go ahead and configure the rsync.conf. So let's go ahead and I have already configured this rsync. So go ahead and add some of the details, and I'll walk you through with some of the information. So you can see that I'm using Swift user, Swift ID, some of the log file, my E0 IP address, and convexum connection to path I'm pointing to SRV node, read only false, and same thing for my containers and objects. So everything looks good. Let's go ahead and save the rsyncd.conf, and let's exit out from that file. By default, the rsync is disabled, so we need to go ahead and enable rsync. So we'll do the etc default rsync, and if you see rsync enabled is false, so we'll go ahead and change this to true. Once that is done, just simply let's go ahead and save this file and exit from here, and let's go ahead and restart the rsync service. So we'll do service rsync, and you can see where the current status is now running. So let's go ahead and do a start or restart, and let's just verify once again. So you can see the rsync service is running now. Let's restore. We'll go ahead and create a Swift Recon cache. So I'll go ahead and create a directory under var Swift for Recon, and I'll make sure that it's owned by user and group Swift. So I'll go ahead and type, use the chon command, change ownership recursively. I'm sure a lot of you already know all these things, so I don't have to detail. So far what we have done, we went ahead and configured two drives for the Swift storage. And if you recall from the presentation when we started, the same VM is going to act as a Swift proxy. Yeah, though you have options to install a different Swift proxy. I'll cover that maybe sometime later, different storage node and different Swift proxy. But for this demo, we'll just stick and we'll go ahead and use the same node for our Swift proxy. First thing we need to do, we need to go ahead and install again the packages needed for Swift proxy. So we'll go ahead and install Swift proxy, followed by the Memcache, and we'll go ahead and install Python Keystone libraries for Keystone, and for the Swift, we'll go ahead and install the Swift client. And not last but not the least, we can go ahead and install the Python web object library. So let's go ahead and install and let me go ahead and press Y. And as you can see, that was pretty quick. We went ahead and installed all the needed packages. And if you just want to see where the package is installed, here's a list of packages: Swift proxy, Memcache, Python, and some of other details. By default, your Memcache listens on the local IP, the loopback IP address 127.0.0.1. So we need to go ahead and change that from the loopback to the actual E0 IP address. So let's go ahead and change that to Memcache, and let's look for 127.0.0.1. And let's go ahead and change this to our VM's E0 IP address. And once that's done, let's go ahead and save the file, exit out, and let's go ahead and restart the Memcache services. So we'll go ahead and type service Memcache. So let's go ahead and verify the status. It says running, and let's go ahead and restart. So let's go ahead and verify. Okay, so it's up and running now. Time for us to go ahead and configure our Swift proxy server.conf. So we'll go to etc Swift and we'll go ahead and create this file, proxy-server.conf. So I'm creating etc Swift proxy server.conf. So I have written all the content. I'll walk you through with these contents. So let me go ahead and add all the data that we need to write into this particular file. And again, as I mentioned, don't worry, what I'm writing, some of the information, I have plans to cover these integrated details. As you can see, the Swift bind port is 8080, and if you recall, that was the port we specified when we created the endpoint using Keystone. We are using user Swift, we are using the pipeline with different arguments. Proxy server, these are some of the information. We are using a filter, Keystone, some of the roles information, authentication. Under authentication, if you have a look at the auth host, we are using our 80 IP address, and if you recall, this is none other the port for the Keystone. Some of the details, tenant we are using service, Swift is the user that we created initially with the password of Swift pass. We went ahead and created a cache with some information, cache errors, and health check. Let's go ahead and save this file. Once that is done, just simply now we'll go ahead and create the rings. If you are not familiar with rings, again, don't worry, I have plans to cover them in great detail. So let's go to the directory again just to make sure we are under Swift directory. Now let's go ahead and create our rings. We need to go ahead and create 3 rings, one for our account, one for container, and one for object. So we have a plan. We will be using 18 partitions for that. So let's go ahead and Swift ring builder account. Now you can see, let me go ahead and do the same for the other 2, and then I'll walk you through. So we are using command Swift ring builder. We are creating rings for account, object, container, and object. We're creating using 18 partitions. And now time to add. Now in this ring, we need to go ahead and add our devices. So when I'm saying the devices, if you recall, we formatted 3 drives as the B, C, and D. Those are nothing but our devices that we need to go ahead, that we need to add under these rings. And I will be using a syntax with the replication IP. Though in this lab, we are not setting up any replication, but I will be doing a demo later on where we will be doing a replication between the nodes. So for the same reason, I will be using the replication IP error. So we need to go ahead and add those drives. So the drive, as you can see, that we went ahead and created 3 rings, one for account, one for container, and one for object. Similarly, we need to add our device or those drives into every ring. So we will be repeating the same command for account, container, and object. So for every drive, we will have 3 entries, one for account, one for container, and one for object. Then again, we need to repeat the same thing for second drive and for the third drive. So the command is pretty easy. Let me go ahead and do that for the first host, and then I'll explain you, and then we can go ahead and do the same for the other 2. I'm sorry, I did not update. Then update my IP error. So let me go ahead and update my notes pretty quick. Let's go ahead and repeat that process one more time. So as you can see, I'm typing a Swift ring builder, account.builder. I'm adding this even zone and I'm giving an IP address of my ETH host. I'm using a port 6002 here. R1 says for R4 replication, that's the replication IP address on the port 6005, and I'm adding STB1 and I'm giving a weight of 100. And we ran the similar command again for container.builder, and we kept the same arguments, the different port number. If you realize here is 6002, this is using 6001, 6005, 6004. Object.builder, port number 6000, 6003, STP. So we just went ahead and added our first drive. So we need to repeat these commands for the other two drives, our SDC and SDE. So let me go ahead and make those changes pretty quick into my notes. And then I'll go ahead and paste that information over here. And then I'll walk you through one more time. So let's go ahead and add the drive number C. I went ahead and ran the same command, and if you have a look, 6002, which matches 6002, 6005, 6005. Rest of the port and details are same. We just changed the drive, and now let's go ahead and do the same for our last but not the least. Okay, I went ahead and added the third drive SDD with a weight of 100. Once that is done, so earlier we created the rings and then we added all these three devices or drives to each ring. Now let's go ahead and verify each ring. So the command is pretty easy. You can do Swift ring builder and then you put the account dot builder, container dot builder, or object dot builder. So I'm typing Swift ring builder, account dot builder, and you can go ahead and press enter. And you can see that there are device ID 0, 1, and 2. They all belongs to the same region. This is in zone 1, this is in zone 2, zone 3. This is my local IP address port, replication IP. Don't get confused, we are not doing a replication in this lab, but just something to keep in mind. Important thing, you can see how many partition, you can do a math. With that one, we have 3 replicas with one reason. So if you recall, when we typed a ring builder, account dot builder, create 18. So this is 2 raised to 18, and we type 3 with 3 replicas, 1 with 1 reason. So I'm sure you all recall that this 100, as I mentioned earlier, this is the weight. And now we can go ahead and verify the same thing for the container. And similar information we can go ahead and verify for the object. Okay, all looks good the way we wanted. Now this is something is good. If you have a big cluster and you want to redistribute, uh, let me rephrase. So what I'm going to do, I'm going to balance these rings. When I say I'm going to rebalance, it means I'm going to generate the rings, file themselves, which can be distributed across the clusters. Okay, so we don't have to regenerate them manually. So the command is pretty easy. Again, we'll go ahead and type Swift hyphen ring hyphen builder, and then we'll do either account.builder, container.builder, object.builder, and we'll specify a keyword of rebalance. So let me go ahead and do that, and I'll go ahead and rebalance all 3 rings. So this rebalancing is going to take some time, so just be patient. Thank you. Okay, so it says a reassigned partition balance is now 0.00, and if you recall, in this cluster we just got only one node, and we are doing the same rebalancing for our container, and we'll go ahead and do the same thing for our object. And as you can see, container is just almost finished, and now we'll go ahead and do the same thing for our object. And once that is done, we'll go ahead and make sure everything inside folder etc Swift is owned by user and group Swift. So we'll go ahead and rerun once again the change ownership command with the recursive. Okay, so the rebalancing is done, and if you just want to verify something, let's go ahead and read in the Swift ring builder recon.builder. And if you see, there hasn't been much changed, but if you noticed earlier outputs, let me go ahead and scroll up a little bit. We were looking at the account.builder in partition 0, but if you look the balance, it says negative 100. And now after rebalancing, if you look, this value is 0, 0. And we are seeing a partition values which were earlier zeros here. So I'm sure now you understand what did really happen after rebalance. So we can go ahead and verify the same thing for the others also. So let's go ahead and check for container, and let's verify same thing for our object. Okay, very good. Now let's go ahead and verify that not all the files. So let's go ahead and make sure everything is owned by Swift user and Swift group. So we'll go ahead and type change ownership with this -r recursive argument, Swift user, Swift group, C Swift. Okay, so we did verify that one. Go ahead and start our Swift proxy services. So we'll go ahead and type service Swift hyphen proxy. Let's go ahead and verify its status first. And let's go ahead and do a start over here. And now we can look for the status and say it's running. So the first thing, we have started the Swift proxy service. Now let's go ahead and start our all the storage services. So there are quite a plenty of storage services. Either you can use a for loop, or you can go ahead and start every service manually, or you could even use Swift-init space all space start. I'm going to go ahead and use the for command just for the all the commands. As I said, you don't have to use, you can type again Swift-init space all space start. I'm using the for command just to start all the services. And you can see there are quite a lot of services. So we went ahead and started the object replicator, updater, auditor, container, same thing for container. There's applicator, there's updater, there's an auditor, account replicator, account, and quite a lot. So you can do manually again, as I said, or you could have typed a Swift-init command and then say all space start. So whatever your preferred choice. So that's all pretty much. Now we went ahead and installed the Swift services, Swift node, Swift proxy. We have started Swift proxy service. We have started the Swift storage node. So everything looks good. So now let's go ahead and verify and see how our Swift system is looking. So I'll go ahead and type Swift stat. It's looking for the keystone, so I'm going to go ahead and source the credentials. Or let's do one thing. Uh, okay, yeah, so let's source the credential from here. And let's go ahead and rerun this command. As you can see, account, we're using account type. And so looks like we are getting a response from this Swift. So now let's go ahead and verify something. So I'll go ahead and create a folder or a files, or whatever you like to call. So let me go ahead and create a directory by name of files. I'll do a cd to files, and let me go ahead and touch a couple of files here. test1.txt. Uh, so we'll go ahead and upload all these three files onto our Swift object storage. So the command will be Swift. We'll go ahead and call it upload. Now we'll go ahead and specify a container name, and it's just an arbitrary name. You can specify anything. I'm just going to call it my file. So I'll say Swift upload my files, and the file I want to upload give the complete absolute path. So I'll go ahead and say root files test1.txt. And if your Swift is working, you just simply see an output of like this: root without any errors or any information. I can enable log, or I can show you open on the console to show the logs, but this simple output indicates that the file was uploaded. Let's go ahead and upload the rest of the other two files. So I'm uploading file 2, and let's go ahead and do the 3. So I just went ahead and uploaded those 3 files onto my Swift storage. They are we have a copy, or they are stored as objects into our Swift storage node. So if you just want to verify that the upload to the container, when I say the container, I'm talking about the smile file, was successfully completed or not, or were there any errors. So I can just simply type here Swift download, and I will go ahead and specify the name of my container, which is my files. Sorry. And you can see in this container, we do see that those 3 files were uploaded successfully. So that indicates our Swift is working fine. We are successfully able to upload the objects, and everything looks good. So this concludes our Swift lab. Maybe in the next labs, I'll show you, as I mentioned, a replication between multiple nodes, or we can move away from single node to multiple nodes, a proxy on a different node, and the storage on different nodes. And this demo, I just showed you how to upload file. Do some of your own research and play around, see how you can upload files. Look through the directories, look through the contents. Just an indication, if you recall that you had mapped any over thing, just go through these files and some of these directories and see what do you get to see, and you can see every folder you will find the same thing: accounts, container, and objects. So I would highly encourage you to play around some of these Swift command. You can see there are quite a lot of commands, so try playing around with the upload, download, and some of these information. I hope this was informative and you liked it, this Swift lab. If there are any questions, feel free to drop them to me, and I would be more than happy to give you an answer. With that, thank you so much and have a good day. Bye-bye.